Imagine for a moment a vast cloud of gas and dust drifting silently in the endless void. This is not just any cloud, it's a cosmic cradle, stretching across the universe, waiting for something extraordinary to happen. It stretches across like unimaginable distances, a cold and silent giant in the emptiness of space. Its darkness hides the potential for creation, a slumbering giant that holds the seeds of stars and worlds yet to come. This is our solar system, billions of years ago, before planets, before light, before life itself. Back then, there was only this immense, swirling cloud, untouched and unformed, waiting for the spark that would set everything in motion. But within this seeming nothingness, a story is about to begin. Tiny particles, invisible to the naked eye, are about to play their part in a cosmic drama that will shape everything we know. It's a story of gravity, that invisible force that draws matter together. Gravity is the silent architect, patiently working over millions of years, pulling and shaping the cloud into something new. Then, a nearby star explodes, sending shockwaves through the cloud and disturbing its delicate balance. This explosion is both violent and creative, compressing parts of the cloud and setting the stage for transformation. The cloud begins to collapse in on itself. Slowly at first, then with increasing speed, the particles of gas and dust are drawn towards the center. The process is relentless, unstoppable, and it marks the true beginning of our solar system's story. As the cloud collapses, it spins faster and faster, kind of like a spinning top gaining momentum. This spin flattens the cloud into a disk, setting the stage for the birth of planets and moons. The center grows hotter and denser, a glowing inferno at the heart of all this swirling chaos. Here, under immense pressure, the first light of a new star is about to ignite. This is the birth of our sun, a star forged in the crucible of gravity. In this moment, the darkness is pierced by the first rays of light, and a new chapter in the universe begins. The sun ignites, bathing the surrounding disk of dust and gas in light and heat. Its energy transforms the cold, dark cloud into a vibrant, dynamic environment, full of possibility. Our solar system is no longer a cold, dark cloud, but a vibrant disk of creation, a cosmic nursery where planets will soon be born. From this swirling chaos, the building blocks of worlds are gathering, and the story of our cosmic home is just beginning. While the sun blazed at the center of our newly born solar system, its planets were still taking shape. Among them was the young Earth, a molten world still reeling from its own fiery birth. But Earth was not alone in its corner of space. Another body, a Mars-sized object named Theia, shared its orbit. The dance of gravity is a delicate and honestly often dangerous one. In the early solar system, collisions were pretty commonplace. And so it was that Theia, drawn by the irresistible pull of gravity, collided with the young Earth in a cataclysmic event. The impact was, well, unimaginable. A collision of worlds that shook the very foundations of the solar system. Molten rock and debris were flung out into space, forming a ring of fire around the battered Earth. Over time, this ring of debris, bound together by gravity, coalesced into a single celestial body. This was no ordinary moon, but a testament to the violent forces that shaped our solar system. This was our moon, forever linked to Earth by this ancient cosmic dance. Let's take a journey through our solar system, calling out each planet as we encounter it. Imagine soaring outward from the blazing sun, passing each world in turn, and marveling at the diversity of our cosmic neighborhood. First, closest to the sun, we have the rocky planets, the terrestrial planets, much like our own Earth, small, dense, and with solid surfaces. These four inner worlds are where we find the most familiar landscapes, from craters to mountains and valleys. Mercury, the smallest and fastest, zipping around the sun like a silver bullet. Its surface is scorched by the sun's heat during the day and freezes at night, creating one of the most extreme environments in the solar system. Venus, shrouded in thick clouds, trapping heat and making it the hottest planet. Its surface is hidden beneath a toxic atmosphere with temperatures hot enough to melt lead and crushing pressure. Earth, our home, the pale blue dot, teeming with life. It's the only planet we know of that supports a rich diversity of living things, thanks to its liquid water and protective atmosphere. Mars, the red planet, once home to flowing water, now a cold, dusty desert. Its rusty surface and towering volcanoes hint at a dynamic past, and it continues to intrigue us as a possible home for life. Moving further out, we encounter the gas giants, these colossal worlds of swirling gas, Jupiter and Saturn. They have no solid surface, and their immense gravity shapes the orbits of many moons and smaller objects. Jupiter, king of the planets, a giant with a swirling storm larger than Earth. Its powerful magnetic field and dozens of moons make it a miniature solar system in its own right. Saturn, the ringed planet, a beautiful giant with a halo of ice and rock. Its rings are the most spectacular in the solar system, and its moons are worlds of their own, some with subsurface oceans. Finally, we reach the ice giants, cold and distant worlds, Uranus and Neptune. These planets are rich in water, ammonia, and methane ices, giving them their blue-green hues. Uranus, the sideways planet, tilted on its axis, rolling around the sun like a ball. Its seasons last decades, and its faint rings and many moons add to its mystery. Neptune, the farthest planet, a dark and stormy world whipped by supersonic winds. Its deep blue color and dynamic atmosphere make it a fascinating, remote giant. Beyond the planets lies a realm of smaller bodies, dwarf planets like Pluto, and the asteroid belt, a band of rocky debris, remnants from the solar system's formation. Farther still, the icy Kuiper belt and Oort cloud mark the edge of our sun's influence, filled with comets and mysterious objects waiting to be explored. Each planet in our solar system holds its own unique wonders. Jupiter, the largest planet, boasts the Great Red Spot, a gargantuan storm that has raged for centuries. Saturn, the ringed beauty, is so light that it could float on water if you could ever find a bathtub big enough. Mars, the red planet, was once much warmer and wetter, possibly even hosting life. Today, it's a frigid desert, but rovers are exploring its surface, searching for clues to its past. And what about Pluto, demoted from planet to dwarf planet? It may be small, but it's a fascinating world with a heart-shaped glacier and a possible subsurface ocean. From the vastness of space, Earth appears as a small, fragile sphere, a blue marble swathed in delicate wisps of cloud. This is our home, a planet teeming with life, a unique and precious oasis in the vastness of the cosmos. But what lies beneath its surface? Let's embark on a journey, a descent into the heart of our planet, to explore the hidden layers that lie beneath our feet. Imagine slicing through the Earth like an apple, revealing its hidden secrets layer by layer. It's a journey few have ever truly imagined, but one that reveals the incredible complexity beneath our feet. You would find that our planet is not a solid mass, but a series of distinct layers, each with its own unique properties, composition, and role in shaping the world as we know it. The outermost layer, the one we live on and build our cities upon, is called the crust. It's the thinnest layer, yet it supports all life on Earth. It's incredibly thin, like the skin of an apple compared to the whole fruit. In some places, it's just a few kilometers thick, astonishingly delicate when you consider the size of our planet. Beneath the crust lies the mantle, a vast region that makes up most of Earth's volume. The mantle itself is divided into the upper and lower mantle, each with different characteristics. The mantle is incredibly hot and made of solid rock, but under immense pressure it behaves more like a very viscous fluid, slowly flowing over millions of years. This is where the Earth's internal heat churns, driving the movement of tectonic plates above. These slow, powerful currents are responsible for earthquakes, volcanoes, and the creation of mountains. At the very center of the Earth lies the core, which is divided into two parts, the outer core and the inner core, each more extreme than the last. The outer core is a swirling sea of liquid iron and nickel. Its constant motion generates Earth's magnetic field, a protective shield that deflects harmful radiation from the sun and makes life possible. The inner core, despite being even hotter than the surface of the sun, is solid iron. It's squeezed into solidity by unimaginable pressure, forming the very heart of our planet. But how do we know all this, when no human has ever traveled deeper than a few kilometers into the crust? Scientists use seismic waves generated by earthquakes to study the Earth's interior. These waves act like messengers, carrying information from deep within the planet. As seismic waves travel through the Earth, they change speed and direction depending on the materials they encounter. By carefully analyzing these changes, scientists can create a kind of ultrasound scan, revealing the hidden depths and mysteries of our planet's interior. The Earth's crust is not a single solid shell, but rather a mosaic of giant pieces called tectonic plates. These plates float on the semi-molten asthenosphere, the upper part of the mantle. Driven by the Earth's internal heat, these plates are in constant, albeit very slow motion. Where plates collide, mountains rise skyward, volcanoes erupt with fiery fury, and earthquakes tremble through the ground. Where plates pull apart, new crust is formed, creating vast underwater mountain ranges called mid-ocean ridges. These plate movements, though slow, are a powerful force shaping our planet. They are responsible for the continent's drift, the formation of mountain ranges, and the occurrence of earthquakes and volcanoes. From the towering Himalayas to the depths of the Mariana Trench, from the fiery eruptions of volcanoes to the devastating power of earthquakes, the Earth's surface is a testament to the dynamic forces that have shaped it over billions of years. And it all began in a cloud of gas and dust, a cosmic nursery where gravity ignited the sun and set the stage for the birth of our solar system. The planets formed, each with its own unique story to tell, and on at least one of these worlds, life emerged, a testament to the wonder and improbability of the universe. As we delve deeper into the mysteries of our planet and the universe beyond, we unlock secrets that have been hidden for millennia. Through the power of science, we piece together the story of our origins, from the Big Bang to the formation of the solar system, from the birth of stars to the emergence of life on Earth. And as we look up at the night sky, filled with the light of distant stars, we are reminded that our journey of discovery has just begun. The universe is vast, full of wonders yet to be explored, and the quest to understand our place within it is one of humanity's greatest endeavors. The answers to some of our most profound questions lie hidden beneath our feet, within the very fabric of our planet, waiting to be discovered.